Okay, example number 2. Let the random variable x represent the time you spend waiting in line at the checkout at the grocery store. Suppose the time is uniformly distributed, with all intervals of times between 0 and 10 minutes being equally likely. So this is uniformly distributed. So what's the probability we'll wait in line? And I should have told you I wanted to change these numbers, and I didn't. So we'll just go with the numbers we have here. So remember, we have between 0 and 10, and the height is always 1 over the length of the rectangle, so that's 10. So what's the probability we'll wait between 2 and 8 minutes? So we need to find this area. So the probability that x is between 2 and 8 minutes, including 2 minutes or 8 minutes, is, remember, the length is 8 minus 2, which is 6, and the probability is length times width, so that's 6 times 1 over 10, which is 0.6. Okay, what's the probability we'll wait less than 4 minutes? So we have the same uniform distribution. Less than 4 minutes is that. And the length here is 4. So the probability that x is less than 4, sorry, less than does not have the equal under it, is still length times width, which is still 4 times 1/10, which is 0.4 if you put it in the calculator. All right. Part C. There's a 33% probability that you wait for how many minutes in line? So this time we have to find the x value because we know the probability. So this is the kind where we're going in reverse. So we know that there's some x value that we don't know what it is, so that the area left of it is 0.033 or 33%. So the probability is length times width. We know the probability is 0.33. We don't know the length. Remember, this is the length. But we do know the width is 1/10. So if we divide both sides by 1/10, being careful to put the 1/10 in parentheses so the calculator doesn't give us a crazy answer, we end up with 3.3 minutes for our length. Okay, example number 3, which is our last example. The reading speed of 6th grade students is approximately normal, with a mean speed of 125 words per minute and a standard deviation of 24 words per minute. What is the reading speed of a 6th grader whose reading speed is at the 90th percentile? Okay, what is the reading speed? That's asking us to find an x value. So find the value of the random variable. so that the student is at the 90th percentile. Remember, percentile means at or below that value. So if it's asking us to find the percentile, the x value that is the 90th percentile, we know we have a mean of 125. Our standard deviation is 24. And there's some x value that we don't know, but we do know that the 90th percentile means that the area below it is 90%, or 0.09. So the key here, when it's find the value of the random variable, that is an inverse norm in the calculator. We have to give it area to the left side, so that's the 0.90. We also have to give it the mean and the standard deviation. And if we do that, we get 155.76 words per minute. Okay, the last one, determine the reading rates of the middle 95% of all 6th grade students. So this is find x values again. And so, let's see, our mean is 125, and our standard deviation was 24. And we need the middle 95%, but we're finding the x values that separate the middle 95%. So if the area between them is 95%, how do we find the numbers in the tails? Well, remember the tails, I'm going to shade yellow, so shade the tails yellow. So to find how much those areas are, remember we start by finding how much area is left over that's not blue. So that's 1 minus 0.95, which is 0.05. That 0.05 is divided evenly between those two tails. So we take it and divide it by 2, and we get 0.025. So each tail has an area of 0.025. And then remember, we have two separate problems. If you need to have a refresher on that, look back at page, sorry, I'm looking for it, at page number 4, the problem at the top. So the B part of it's page 4, example 2B, and that should help you do this. So to find x1, it's inverse norm. The area to the left is 0.025. We already know that because it's labeled clearly on our graph. It's the left yellow tail. The mean is 125. The standard deviation is 24. So we get an X value of 77.96 words per minute. That gives us our lower boundary, the X1. Now to figure out X2, we have inverse norm, and we need to figure out the area to the left of that. We know the area to the right is 0.025, so we need to do 1 minus 0.025. That's the area left of X2. So that is 0.975. So 0.975 goes in for area, 125 for mean, 24 for standard deviation, and when we plug that in, we get 172.04 words per minute. Okay, remember, as always, if you have any questions, please don't hesitate to contact me. I am more than happy to help you through text, email, phone call, Zoom conference, whatever it takes. Don't be shy. I promise I don't bite. The few of you that have contacted me know this. I hope you tell the rest of your classmates.